Despite popular belief, there's more to our 5-pound mushy membrane than just billions of bundled neurons. There's other cells. Cells which those attention-hoarding neurons need to function properly. And likely function at all. Which creates a rather interesting dependency for our cognitive function. You know, the thing you're doing right now as you process what's coming out of my mouth? Cool. I know. But that's actually just the beginning, because it just so happens these supporting cells are modulated by external and internal factors such as diet, obesity, and everybody's favorite quasi-organ, the microbiome. And this new research found the common X factor, linking them all together. Here's what you need to know. Yo, what is up? Welcome back to another week of How to Health. My name is Kevin. I run liftandbalance.com, where we take aim at all things health and longevity and do it in an odd, weird, interesting, and highly sarcastic way. So back to these supporting cells, because you probably noticed I didn't mention what they are and what they do. These neuronal unsung heroes are glial cells, which are specialized cells in the nervous system that support, protect, and maintain neurons. However, the ones that we are going to hone in on today are a specific type of glial cell, unique for their role as the immune cells of the central nervous system, conveniently named microglial cells. I know. Finally, biological terminology that kind of makes sense. Enjoy, but don't get used to it. And here's why these neuronal immune cells are so important. Microglial cells are like the brain's security guards, keeping things in check by cleaning up debris and helping shape brain connections. And interestingly, they play a big role in how we think and remember, specifically by maintaining neuronal connections and pruning unnecessary ones, making them pretty damn critical for one of our human superpowers, neuroplasticity, or our ability to establish and build new neuronal connections that facilitate us learning and picking up new skills. But here's the thing. The data has shown that when they start losing their efficiency, we can almost certainly pencil in a cognitive hit, as this happening has a direct impact on many of the biological prerequisites for neuronal performance, driving a noticeable impairment of one's brain blast capacity, which I think everyone would agree ain't cool for biological school. And it is this which led a research team out of Spain to explore what exactly are the driving factors of the dysfunction behind these brain cells tied to the livelihood and prosperity of what many would call our most valuable asset, our mind. And if there's any way to flip the script, spoiler alert, there likely is. Here's what they found. To explore this very connection, researchers honed in on two phenomena that have been known for a while now. First, that obesity-related cognitive decline is linked to gut microbiota dysbiosis. And second, that a key mechanism that both act on to drive this decline seems to be microglial dysfunction. So, they did what any right-minded scientific team would do, and set up a study that would institute change to the microbiome and obesity-related markers, observing if and how they would affect cognitive function, specifically looking at changes in markers of microglial function. And one of the best ways to do just that, the microbiome and obesity marker manipulation, is with a structured and specific dietary intervention, which is exactly what they did, randomizing 96 participants with obesity into 3 dietary intervention groups: a Mediterranean diet, a alternate day fasting or ADF diet, and a ketogenic diet for 3 months, conducting cognitive performance, tissue analysis, and microbiota composition assessments pre and post intervention, while also running a number of in vitro and mouse models to further explore its effects directly on microglial function. Now, it's important to note that all 3 diets were programmed for a 600-calorie deficit per day. So with that, and the noted preference for real food, these protocols were built for improving metabolic function and weight loss. Also, the ADF alternate day fasting group was not really alternate day fasting, but they kind of were too. So it's important to understand how that was done as well, which essentially was alternating between eating normally one day and eating only 25% of caloric needs the next day, really making this ADF group semi-fasting, in my opinion. With that, let's see what they found. Starting with body composition. BMI, waist, and hip circumference saw decreases across all three groups. Good start. However, the most significant increase was observed in the keto group. Now, when it came to fat and lean mass, once again, all three groups saw decreases, which is great. But again, the most significant results were observed in the keto group, making avocado lovers everywhere cheer. And lastly, on the body weight front, the most significant changes were observed in both the keto and ADF group. And when it came to energy expenditure while resting, or basal metabolic rate, the ADF group registered the highest increase after the 3-month intervention. That being said, all of these were secondary outcomes. Let's move to what the researchers really want to see. When it came to cognitive performance, the combination of tests performed suggested that the ADF intervention was more successful in driving cognitive improvements than keto or the Mediterranean protocols, with the ADF participants registering better results for inhibitory control and working memory. Interesting. And when the researchers tried to put a finger on what may be driving these better overall outcomes, their first hypothesis, a greater circulating supply of ketone bodies, was invalidated due to lack of differences between the three groups. So they then turned their attention to the next logical driver, inflammation, finding a significant decrease in several inflammatory markers such as ferritin and MCP1 in the ADF group compared to the Mediterranean and keto diet. You don't say. And to further investigate this anti-inflammatory effect, microglial cells from participants were studied in vitro before and after the intervention to measure their functionality, finding that the ADF group cells showed enhanced phagocytic function and a less inflammatory profile. You don't say again. Having the researchers conclude that these findings support the idea that microglial modulation is a key link in the microbiota gut-brain axis, mediating cognitive outcomes. Now, you may be wondering, where do the gut bugs come in to all this? Right here. To explore one of the ways a dysfunctional microbiota may affect microglial function, researchers treated the in vitro microglial cells with exosomes from an obese microbiota. These are bacterial byproducts that could very well be making their way into the brain in a scenario of leaky gut, or when the tight epithelial cells of the gut wall begin to separate, becoming more permeable and allowing things to pass that shouldn't. And as you may recall from this video here, leaky gut is tightly associated with leaky brain, or the dysfunction and increased permeability of the oh-so-critical blood-brain barrier, allowing things that shouldn't get on up into the cranial cabinet. Here, researchers found that prolonged exposure, which mimics chronic exposure in obesity, drove the in vitro microglial cells to lose their function, increasing markers associated with dysfunctional microglial implicated in processes such as neurodegeneration. Suggesting that microbiota diet-related changes affect microglial function and could mediate the long-term cognitive decline associated with obesity. Bringing us to the pretty logical conclusion, we should probably try and not do things that drives the underlying dysfunction which upregulates chronic inflammation, because that seems to be the common denominator here. So here are some things to keep in mind. To keep your mind. Yeah, you see what I did there? Anyway, the low-dose arousal of the immune system, aka chronic inflammation, happens to be one of the common variables in just about every disease state there is. Thus, why we call it longevity liability numero uno and have been doing so for years. And when it comes down to it, a lot of this suboptimal inflammation is driven by common factors. On the internal side, there's cellular dysfunction and more specifically mitochondrial dysfunction, causing an increase in free radicals, oxidative stress, and resulting cellular damage, and as a byproduct of this damage, a flurry of inflammatory markers which elevates immune activity. And then there's the externally driven inflammation, ironically mostly being derived from inside the body, with the home base being the large intestines where trillions of non-self bacteria reside. Now, as we discussed all across the Microbiome 101 playlist, these gut bugs are actually key for healthy and optimal biological function. In fact, they have been shown to secrete critical brain-boosting metabolites, such as short-chain fatty acids, which reduce inflammation in the brain by driving glial and microglial efficiency. Gimme some of that. I know. However, as we also know, it's all about context. Because once the barrier, aka gut wall, which has been evolutionary built to keep those microbes in their place, breaks down, inflammatory hell begins to break loose. As bacterial byproducts and metabolites which are not supposed to enter the body sneak right on into the hottest biological club in town, club circulation. And when they do, the chronic inflammatory storm begins, as we broke down in this video here. And as we mentioned before, leaky gut is often associated with leaky brain, which is when the tightly junctioned endothelial cells which make up the blood-brain barrier, strictly governing only approved compounds and nutrients into the brain, breaks down, essentially opening the neuronal VIP section to harmful compounds. To use the previous example, things like bacterial byproducts, thus driving inflammation. And when you combine this with the likely cellular and mitochondrial dysfunction happening at the same time, this inflammatory effect compounds to some pretty nasty places. So, if you happen to be wondering what some of the root causes of this cellular and microbiota dysfunction may be, the reality is a lot of it can be traced back to lifestyle, with some of the biggest culprits that we talk about ad nauseum across the hundreds of videos on this channel being the ultra-processed, 24/7, energy-dense, nutrient-scarce Western diet, ultra-sedentary indoor living, chronically deprived circadian disaligned sleep, excess chronic stress, or the activation of the fight-or-flight nervous system for reasons not associated to immediate survival, like scrolling news and social feeds, and the use and overuse of harsh chemicals in cleaning supplies, body care items, and everyday products. All of these factors are at the foundation of cellular dysfunction, metabolic dysregulation, obesity, gut and brain barrier breakdown, and the cultivation of a suboptimal microbial community which exacerbate all of this through the compounds they secrete. So yeah, taking that lifestyle seriously may be the best anti-inflammatory there is. And here's the best part. The most impactful modulators are basically free 99. Yeah, they don't cost a dime. Only time. And some discipline. Oh, and likely a little flatulence from all those good microbes saying thank you for the real food. It's natural stuff. Just make sure you're in a ventilated area. Trust me. But other than that, free 99. So get out there and go own it.